Okay, in question 4 of tutorial 2, we're going to compare Fisher's money demand to Keynes' money demand to Friedman's money demand. And the way we do this is we have these assumptions up here. We have the price level is equal to 1. The money velocity is 1.5. Real GDP is 13,650 billion, or 13.65 trillion. The expected return on bonds is 1.7%. The expected return on stocks is 4.4%. And the expected inflation rate is 3%. Now, this looks familiar. What I'm calling Fisher's money demand looks familiar because it is a rearrangement of the equation of exchange. The equation of exchange is money, stock, times velocity equal the nominal rate of interest, the price level times real GDP. And all we do to get the money demand equation is we add a D here. We divide both sides by velocity. We divide both sides by the price level. And what we're left with is what I call Fisher's money demand. This over here is real money balances. And the cool thing about this problem is the price level was set equal to 1. So the way you can think about this is we're looking at we're estimating Fisher's, or we're calculating Fisher's money demand equation in the base year of the price index. Because in the base year of the price index, remember, the price level is always 100% or 1.00. Okay? So let's go ahead and erase all that. The price level, again, is 1. So that right there is 1. So that's why we have MD here, money demand. The GDP level is 13,650 billion, or 13.65 trillion. We're going to divide that by the velocity. And the velocity is 1.5. Right? I'm going to copy that over to Excel to have Excel do the arithmetic for me. And I get 9,100. Okay? 9,100. And I'll hit enter to see if I got it right. And it looks like I did. Okay, now down here, what I'll do is I'll go ahead and graph it. Money demand. This is saying money demand is a vertical line in the space where this is the nominal rate of interest and this is the quantity of money. And over here we're saying the quantity of money is 9,100, right? And down here it says the quantity of money held is 9,100 billion, or $9.1 trillion, when the nominal rate of interest is 5.04%. So when the interest rate is high, 5.04%, the quantity of money is 9.1 trillion, or $9,100 billion. Then I go on to say, well, the quantity of money held was 9,100 billion when the nominal rate of interest is 4.13%. So this is saying money demand is perfectly inelastic, right? Perfectly inelastic. We want to calculate the elasticity of Fisher's money demand. Okay, you got to remember that an elasticity is the percent change in a quantity, right? In this case, M, right? Over the percent change in price. In this case, the nominal rate of interest. Right? So the percent change in quantity is 9,100 minus 9,100, right? Divided by what it was, 9,100. The percent change in the price is, it was 4.13, it is 5.04. So 5.04 minus 4.13 divided by what it was, 4.13. Well, we don't even have to calculate this because up here, 9,100 minus 9,100 is 0. 0 divided by that is 0, right? So whatever this is, we have 0 up here. This all here is 0. So the elasticity on Fisher's money demand curve is 0. What that means is when the elasticity is 0, that means demand is perfectly inelastic. So we're going to go ahead and hit enter here. And I'll go ahead and erase everything. And we'll move on to Keynes's money demand. Keynes's money demands a little differently. It's a little different. We have real money balances right here. And in Keynes's model, real money balances is a function of real GDP or national income and the nominal rate of interest. The nominal rate of interest is negatively related to the real money balances, whereas income is positively related to real money balances. Okay, so what we have to do here is we want to remember money demand price is the interest rate. The quantity of money is M. So what we need to do is we need to solve this for I after we plug in a value for Y. Okay, so we're going to take, let's just write this out, I guess. Let me get a thinner pen. Remember, P is 1 here. We assumed P was 1 in our problem, right? P is equal to 1 up there, right? Price level is 1. So that right there is 1. So we need to plug in a value for Y here, right? And the Y is that value right there. Okay, so let's do this. We got MD equal to 2.696 times 13650 minus 5495I, right? Okay, so we have to calculate this number here. So let's open up an Excel. I'm going to calculate that value, 2.696 times 13650, and that equals 36,800.4. So I'm going to go ahead and get the eraser here. I'm going to erase this part. Okay, then I'm going to get my pen back. And I'm going to write 3680.4, right? Okay, now I got to solve this for I, right? So I'm going to add this quantity to both sides. I'm going to subtract this from both sides. So that leaves me with 5495 I equal to 3680.4 minus M D, right? Okay, now I got to divide both sides of the equation by this value. 5495 here. I have to divide that value by 5495. And I got to divide this side by 5495. Okay. So I'll go up here in Excel and I'll take this intercept value and I'll divide by 5495. And this gives me the intercept of the equation. So I'm going to go over here and erase. I'll erase this. And I'm going to erase this value because I just calculated it right. This value was 6.69707, right? So I'll just go ahead and type it in. That's the intercept. 6.69707. Okay, so let me just copy it. Copy. Well, 6 decimal places, right? That's cool. Let's go back here to Excel. That is 6 decimal places, right? 1, 2, 3, 4, 5, 6. I don't need the 0 there. Okay, there we go. Okay, good. Now I need 1 divided by 5495, right? Because the coefficient here, the coefficient of MD is 1, right? So I got to divide 1 because I divide 1 by this value here, right? 5495. That gives me the slope of this equation, of that equation. Okay. So what I'll do is I'll just grab this and right here I'll paste it and I'll just get rid of C2 and replace it with 1. So the slope to 6 decimal places, 2, 4, 6, right? That's 6 decimal places. And I'm going to hit enter to see if I get everything right, and I should. Good, I got that all right, correct? So I'm going to go ahead and erase all that stuff. Now I have an equation with a relatively small intercept and a slope really close to 0. So I'm going to use this equation above with the intercept and the slope rounded to 6 decimal places to answer the following. What I'll do is I'll go ahead and get I'll graph my equation again, or I'll graph my money demand equation. So remember, money demand, whoops. Let's use black, we'll use red. I won't use such big ink this time. So if I graph this equation, it's downward sloping, right? This is Keynes' money demand. And I got 2 points on the graph. Okay, initially, it is, or so in the end, we have 9,100. Quantity of money is $9,100 billion. And then I got to calculate the interest rate. If the quantity of money held was 14,100, right? 14,100. So I got 9,100 and 14,100. So I need to calculate the interest rate using this equation rounded to 6 decimal places. So let's go back to Excel. Now the problem with these two numbers is these aren't really rounded. So what I'm going to do is I'm going to go down here and type equal round. Then I'll go up here and I'll type comma 6. So what does this do? It rounds that explicitly to 6 decimal places. And I'll do the same thing here. Round the slope to 6 decimal places. Okay, so now when I add decimal places in Excel, right, you can see that this one's not really rounded to 6 decimal places, nor is this one. But these two are definitely rounded to 6 decimal places. Okay, so I need to use this equation right here. I equal to this minus that times the quantity of money. And the quantity of money is what? It is 9,100, right? And it was 1,000 or 14,100. Okay. So I'm going to calculate the interest rate when it is, when the quantity of money is 9,100. So I first need to get the intercept. Then I need to subtract off the slope, which is then multiplied by the quantity of money. See that? So C5 is this value, the value in the blue, minus D5, which is this green box here, or that red box there, times the quantity of money. In this case, 9,100. Okay. I can reduce the number of decimal places to, I guess, well, I'll keep it at 6. How about that? 2, 4, 6. Now, if I pull this across, what happens? Uh-oh. I got to pull these back, right? So C5 is the intercept minus the slope of D5 times this quantity money, what the quantity money was, 14,100. So I have an interest rate of 4.13% and an interest rate of 5.04%. Those look familiar. Let's look. Oh, those are the same interest rates here, right? Same interest rates. So now I got to calculate the elasticity here, right? So those are the same interest rates as I had in the above one, right? So when the quantity of money is $9,100 billion, the interest rate is 5.04%. When the quantity of money held was 14,100, the interest rate was 4.13%. Okay. Now I got to calculate the elasticity, right? So I need the percent change. I need the percent change in quantity and I need the percent change in price, right? Our percent change in quantity, remember quantity is money here, right? So our percent change in quantity is what money was minus, or sorry, what money is minus what it was divided by what it was, right? That's the percent change in the quantity of money. I pull this down and I get the percent change in the quantity of interest rates. And remember, the interest rate is the price of money. M is the quantity of money, right? M is the quantity of money. So this is the quantity of money. That's the price of money. So this, if I multiply that by 100, I get the percent change in interest rates, or the price of money. If I multiply that by 100, I get the percent change in the quantity of money, right? So now what I'm going to do is I'm going to take the ratio to get the elasticity. The elasticity is the percent change in the money divided by the percent change in the price of that money. So the elasticity is 1.6, 2 decimal places, 61. And it's negative. So I'm going to hit enter and everything should be correct. And it is, right? It is. Okay, cool. I'll go ahead and erase my stuff there. Now Friedman's money demand is a little bit more complex. Friedman's money demand, real money balances, is a function of what Friedman called permanent income. And you can think of permanent income as a future value of what national income should be. And to make it simple, we'll just change it to GDP here. So if the economy doesn't grow and GDP has been at this value for a long period of time, that'll be potential GDP, or permanent income. So we'll just make it simple and call that this right here real GDP. And permanent income is a function of GDP. If GDP is relatively low, then permanent income will probably be relatively low. But if GDP is high, then permanent income will be high. So it's not too far of a stretch. It's how we can compare them, right? So this is really permanent income, but we'll just assume that permanent income equals real GDP. And then we have the nominal rate of interest. So that kind of looks like Keynes. But on top of that, Friedman also had these differences in the bond return and the money return. The differences in the return on stocks and money return, or equities. And then expected inflation minus the real rate of interest, or the return on money. Okay, so R here is a return on money. Okay. And we're going to make a simplified assumption that the return on money is equal to the real rate of interest, to make it simple. So what we're doing is we're replacing the green values here. We're replacing the green values with that right there, just to make this simple. So we're going to plug this into here. We're going to plug that into here. We're going to plug that into here. And then we're going to factor all the i's. So we have an I. We have an I here. We have an I here. And we have an I here. Okay? All right. Also, we have a expected inflation here, an expected inflation here, and an expected inflation here. And that's why we end up with 4 times expected inflation. We have 1 return on equity, and we have 1 return on bonds. And then all these have the same coefficient. So we're just doing our algebra, and then we're collecting terms. Okay? Because we have I here, and that's times that and that. That explains this value here. And then because we had, remember we had an I here, we have an I here, and we have an I here. We have 3 i's, which explains that. And they're all multiplied by this value. Okay, so that's just arithmetic. We're plugging this into there, there, and there, and then just collecting terms. So it's just factoring. You know, this is beyond the scope of the course. You can get math programs to do this for you. So trust me that this, with this identity, simplifies into that. Just trust me on that. Okay. Now, with the price level equal to 1, remember, we just have on the left side, MD divided by 1, money demand, right? Just money demand. Okay, and then we plugged in the value of real GDP here. This is the return on bonds. Right here, 1.7. The expected return on stocks is 4.4. That's why this is 4.4. And then this 3 here is expected inflation, which is 3. See that? And then, so it's just a matter of doing arithmetic. So what I'm going to do is I'm going to copy this value. I'm going to copy all of this into Excel. This right here. This right here is the intercept of an equation in money demand. So I'm going to copy and paste that into Excel. I'll put it right here. Okay, I got to change that dot to times in Excel. Got to get rid of the space in front of that equal sign. So there's nothing in front of that equal sign, right? Get rid of the spaces. Get rid of the spaces, spaces. I got to add in a multiplication there. And if I hit, oh, and I got to change this to multiplication here. That dot there is multiplication. That's 4.4, that's 1.7. Get rid of the spaces. So this right here is M equal to something, right? Okay, now we got to calculate the slope. That's the slope of the equation. So I'll paste that in there, change that to an equal sign, change that part to times, and then change this to times. And that's the slope. And this is I here, right? I. Let me do this. I'll put a minus right there, right? So this is my equation, right? That's my equation there. In terms of m, right? So this equation right here, in my open math, that right there simplifies to the thing in the yellow box. Now down here, this is solved in terms of I. So what I have to do here is I have to solve this for I. It's solved for m, but I want it in terms of I. So I'll put it right here. M equal to 14,632.7 minus 1099 times I. Okay, so I'm going to add this quantity over, and I'll subtract this quantity over, leaving me with this here, right? And I'll just write times one times m, right? 1 times m is m, right? So make it maybe simpler. Now I'm going to divide both sides of the equation by this 1099. So I'm going to divide this by 1099. And I divide the 1 by 1099. Okay, then I can use the eraser to erase this from the left-hand side, right? Okay, so my intercept is this ratio, and my slope is this ratio. So over here in Excel, I'm going to type equal that divided by the slope, right? Whoops. Sorry. Okay, let me just click on it. So the intercept is this big value divided by that smaller value, and you get that, and it's got to be 6 decimal places, right? 3, 4, 5, 6. I'll copy that. I'll put it here. Okay, and the slope is just the inverse of that value right there, right? 1 divided by 1099. Hit enter. And I'll go up here. Okay, there's 4, 5, 6. So I'll copy that and I'll paste it right here. Okay, let me go ahead and erase all this. Let me just actually, yeah, there you go. And scroll this up. Okay, so using the above equation with these values rounded to 6 decimal places, so I need to go up here. I need to literally round them. I'm going to use round, arrow up, comma, 6, and then, so I'm rounding that to 6 decimal places, and I'm rounding that to 6 decimal places, and I'm using this to make the calculations. So you can see that this is not rounded to 6 decimal places, even though it looks like it's rounded to 6 decimal places, right? Same thing over here. So in Excel, you have to literally round it. Okay, that's 4, 5, 6. Okay. And then down here if the quantity of money is 9,100, so I'll copy this. Okay, so if the quantity of money is 9,100, right? I want to know what the nominal rate of interest is. So I have C11, which is this value here, minus the slope, this value here, or there, times the 9,100, right? And I hit enter. Okay. And then I do the same thing. Oh, I got to change this value right here. See that? This value is 10,100. So I'm going to copy that. I'm going to paste it right here. So I got a different quantity for this part. 10,100. So when I plug this into my money demand equation, where I got C11, which is that value, or that value, minus the slope, that value, or that value, times this new quantity of money, $10,100 billion, I get an interest rate of 4.12, which is kind of close to what it was before, right? So this is 4.12, and then this is 5.03, so it's really close to the values above, right? Here we had 5.04, now we got 5.03, and then we got 4.13 and 4.12. Okay. Now we got to calculate the elasticity. So the percent change in the quantity of money is what it is minus what it was. That difference divided by what it was times 100, convert it to a percent. For the percent change in the price, what the nominal rate of interest is minus what it was, that difference divided by what it was times 100. And of course, elasticity is the ratio of the percent change in the quantity of money over the percent change in the price of money. And it's negative 0.44865. And I want 2 decimal places, right? So that's a 5 right there. Now I'm going to hit enter, and I should get everything correct. Except for the last 2 answer boxes down here, right? So let's go ahead and answer the questions down here. Well, when you cut this out, you have to label which one's which. I'm not going to do it for you because that would just be too easy. I'll let you figure it out. Okay. They're all money demand, right? Money demand, money demand, money demand. The price the price of money is the nominal rate of interest, which we talked about in the notes, and then the quantity of money is M, right? And the well, this is an equilibrium here. I have one economist version of money demand. I have another economist version of money demand, and then I got a third economist version of money demand. One of these 3 money demand equations is Fisher's, one's Keynes, and one is Friedman's. And you have to figure that out. Okay? I'll let you figure that out on your own. Let me go ahead and erase. Here's a hint. Is this a function of interest rates? Money demand is always, the quantity of money is always 9,100. Is this slope smaller than this slope? 0.0009, 0.0001. That's the hint for which one of these is the Keynes's money demand. Okay. Now, because this elasticity is 0, this elasticity is negative 1.61, and this elasticity is negative 0.045, the most inelastic demand equation is the one with the elasticity closest to 0, in this case, Fisher. So you could say inelastic here. hit enter, and everything but one should be answered correctly. And then you can figure out which of these choices here, A, B, C, D, or E, goes in here. Okay? So for your homework memo, screenshot this graph, label this nominal rate of interest I, label this the quantity of money M, and then identify these three money to demand equations as either Friedman, Fisher, or Keynes.